In order to determine the deflection of, for example, let me start with point E, this point E. In order to determine this, we have to know the elastic curve, okay? Elastic curve. Using the moment area method, we need to have the concept of the elastic curve, how the element is going to deform. That's the elastic curve. How this beam is going to bend when this kind of loading is applied on it. So now let me show you the elastic curve of this element. Let me redraw. This is the bending moment diagram. So the bending moment diagram divided by EI will give me the M over EI diagram. So here we have the first area, area 1, area 2, area 3, that is a negative, area 4, and area 5, and then area 6. These are the 6 areas that we have. From here up here it is 0, so we don't have M over EI region for this portion. Now the possible elastic curve for this beam is something like this. One of the possible elastic curve is something like this. So point E will come to this point. This is E. So let me draw a tangent at point A. This is my tangent. So from here up to here, we will call it the translation of E with respect to the tangent A. And from here up to here, from this point up to this, we will call it the translation of, this is C, okay, this is A, this was E. Okay, the translation of C with respect to the tangent A. Now this is the actual translation of E, so it is the translation of E, okay, from here up to here, the translation of E. Now if we want to determine the translation of E, we need to know the system that I am going to follow is, I will determine this one from this, and by similarity of triangle I can calculate the total. Then I can determine this, the translation of E with respect to A. Then by subtracting from the total I can get the translation of E. So let me do that. Now for this is point A, this is point C. So from point A up to point C, we have 1, 2, 3, 4, 5 regions. Okay, so the total area of the total moment of area of this region will be the translation of C with respect to A. So let me do it one by one using the table. Here you have to take care of the signs, okay? When the region is under negative of M over EI, you have to use the negative of M over EI and so on, okay? So let me do it that way. Using the table, we see here that M over EI is given here, and here we have the centroid of each region from the y-axis. And now when we are doing the translation of C with respect to A, the centroid of each area in between A up to C will be measured from C, from here, from this one. So for example, for this one, the x bar 1 equals 2 over 3. But what I want is not from here up to here, it is from here up to C. So it will be from here up to here مثلا. okay, so this will be my x bar prime. We can say it like that. Okay, so the x bar prime for every area should be calculated. So I have calculated it and I have put it here. It will be what? The distance from here up to here is 4 meter. So if you know this one, the total, so for this one it will be 4 minus 2 over 3, so you will get it. For this one, we know the distance from here up to the centroid. Again, for area 2, it is what? Somewhere here. From here up to here, it is 1.66 something. So I will measure from here up to here. It will be 4 minus 1.665, and this one is 5. So 1.665. So this will be the one that I am going to use here. Okay, so x bar prime 1, x bar prime 2, x bar prime 3. So all these values are tabulated here. Now the total moment of area will be the area m over ei multiplied by x bar prime of each area. So the sum of these is equal to here. So it is equal to TC with respect to A is found to be 10 over EI. In a similar fashion, we have to calculate TE with respect to A. It is the total area between A and E. So it is this plus this minus this minus. These are negative areas. So again, in a similar way for this one, we will determine the x, the centroid of each area with respect to E. Okay, we know the area of each element. For example, for area 1, we know that it is from here up to here, it is 2 over 3. But for TE with respect to A, we will measure from this point E up to here. Okay, so it will be 6 minus 2 over 3. So in this way, I have done all the calculations, and it is put here in the table form. Now, so we said that this is point E, and we drew a tangent from here like this. Okay, this is our tangent, this is tangent A. So we said that the distance from here up to here is already calculated. This is our point C. It was here point E. Now how do you know that point C is here? Because we have a support here. This support will not move up or down. Okay, it will be in its position because we are already given here a roller support. So the distance from this C up to here, up to this tangent, is already TC with respect to the tangent A. And here the distance from the current location of E, because the loading was downward and the bending moment was negative here, it will move down. So the distance from here up to the tangent is named the translation of E with respect to tangent A, and it was originally here. So the actual movement of point E is from here up to here. So this is what we call it, the translation of E. Now this one is already found to be TC with respect to A was found 10 over EI, and the translation of E with respect to the tangent A is already found to be negative 1.6666 over EI. Now here the value is negative here. So this negative indicates for us that the tangent is not below here, rather it is above here. Okay, anyhow, if we use what we found here in our calculation, it will not cause us any problem, but it is a point that you have to know that if you have got a negative value here, it means that this point is not above your tangent, it's already below your tangent. Okay, so let me continue. Now you have the total distance from here up to here. Let's call it from here up to here, let's call it h. So by similarity of triangle, the distance from here up to here is known to be 4 meter, and from here up to here it is 2 meters. So the total distance is 6 meters. So by similarity of triangles, we have the vertical distance h divided by the total length 6 must be equal to this one, translation of c with respect to a, divided by this distance, that is 4. So from here h will be equal to 6 over 4, the translation of c by a. So this is equal to 1.5 times the translation of c with respect to a. This you will get 15 over ei. So now we know that h equals te plus te with respect to a, right? So here, from here, what we get is h. From here, what we get is h equals te plus te with respect to a. The translation of e plus the translation of e with respect to a. So let's substitute the values. H equals how much? We have already found here 15. 15 divided by ei equals te is the one that we don't know. This will be minus of negative 1.666. This will be minus 1.666 over ei. So when this comes to the other side, you will get that te will be the h plus this value. That's what we said earlier. So the translation of e equals 15 plus 1 point something, so it will be 16.6666 divided by ei. Now let's again come to determination of e and I. E is already given to be 200 gigapascal. Okay, so and it's equal to 200,000 kilonewton per meter square. Okay, because our moment is in kilonewton meter, our x was given in meter, so let me give it here kilonewton and the area in meters. Okay, area in meter square, and the other is I. Now we have a cross section that's like this, a rectangular hollow section. So here you have a breadth, you are given here to be 100 millimeters, and here you were given 200 millimeters, and the thickness is only 5 millimeters. So the actual moment of inertia will be equal to the total moment of inertia. Let me call it I out minus the inner moment of inertia, because it's a hollow, I in. The outer one is equal to B is 100 times H is 200 cubed, all divided by 12, minus the inner one is, this has a thickness of 5 millimeters. Okay, so the inner width will be 90 millimeters, and the inner depth will be 190 millimeters. So it will be 90 times 190 cubed, all divided by 12. So you will get from here 15224 167 millimeter to the power of 4. Okay, you have to change this one into meter, so you will get this to be equal to 15224 times 10 to the power of minus 12 meter to the power of 4. Okay, so this will be my moment of inertia, this will be my modulus of elasticity. By inserting this into my equation, I can calculate the translation of E like this. So from this I have the translation of E will be equal to 0.0055 meter. This will be my last answer for the translation of point E. This is a translation of point E. If you want to calculate the translation of point B, that was a point here, it was here, okay, B is here. How are we going to calculate? So simple, okay, let me do that. Now this is how it is. So this is our point B. It was here and it has moved down to this point. So this is the translation of point B. But from here up to here, it is the translation of B with respect to the tangent A. This is the translation of B with respect to the tangent A. So simply, the distance from here up to here is known to be 1 meter. 1 meter here. And the total distance from here up to C is known to be 4 meters. So you already know this. So what you have to do is the translation of B with respect to A can be calculated by the moment of the area between this and this. So by doing that, you can simply calculate this one. Then you can, by similarity of triangle, this over the total distance here 4 meters must be equal to this total distance divided by this. So you will find the total distance from here up to here. Let us call it capital H. So after finding capital H, you can simply subtract capital H from you can subtract this from capital H, and you can simply calculate the translation of B. So take this one as a homework. Please write your answer on the comment box. Thank you for watching. See you next time. Now let me show you how to model and calculate the deflection using a simple way, using a software SAP 2000. I hope you will enjoy watching this. I will do this in a few minutes, so let us see them one by one.